Cables and connectors. In this nugget, we'll be discussing cables and connectors. This is a short video where we'll discuss the three main types of cable that you might find. Really, this one's going to be kind of rare anyway, but it's coax cable. It kind of looks like what you see coming out of the back of your TV, but there's several different forms of it and implementations. We'll also take a look at the connectors for coax and then for fiber as well. Even though most A+ technicians probably won't touch fiber an awful lot, we'll just give you the basics of what's available and what you might see out there and what the advantages of it are. We'll also take a look here at twisted pair cabling. This is by far what you're going to see the most of. And that's what Ethernet networks commonly use, and you're probably going to see these in speeds of 10, 100, or a gigabit per second, depending on the network cards and network devices that are in your network path. Now, as we get started taking a look at various types of cable that we would use in our networks, let's start here with the old coax cable. I haven't really seen this for probably 15 years or more. In fact, the last time I really remember seeing this in production was for an organization that paid us to come in and rip it all out and replace it with twisted pair cabling instead. This cable was so old that if you would bend it, you could see the outside insulation, the rubber on the outside, you could see it crack. So that's how old it was. Anyway, so I don't really want to spend a lot of time here because I doubt very much that you'll see much of this in real life and possibly very rarely even on an A+ exam, even though it's listed there. RG6 is one of the oldest types of cable that you could use. This one's used for old satellite TV, for example, not the ones that we use now where you can just, put them on your roof, a little tiny satellite dish that's probably a 1.5 inches across. These were the ones that were several feet across. Okay, this is a very big, thick, heavy cable. Rarely see it anymore. RG8 is very often going to be used for the bus type of a network, for the backbone, or for the trunk, for example, and that would be what you would want to tap into if you were a client trying to tap into the bus. This would be the bus, the main bus type of that. And then from the client side, you'd probably be connecting RG58 on the client side to connect to that RG8. Okay, and there's a number of different ways of doing that, which I'll talk to you about when we look at connectors. And then there's RG59. This is just conventional television cable. I also have a table, by the way, that will outline a lot of this for you, kind of be a good study guide for you, but here we'll at least get the overall view of this. Now, one thing I want to point out before I forget, and I've made a note to myself here even about this, is that with coax cable, if you do use it, you want to avoid sharp bends, because what happens is it gets this kind of a signal bounce in it. So if you bend it any more than usually 90 degrees, then you can get a bad signal out of it, and you might have a lot of retransmissions. You just have to be careful of that when you're putting it around cables and your cable runs and stuff like that, or if it's underneath the desk and it's, the computer's gotten shoved back and it's gotten a crimp in it, that sort of thing can affect the signal quality of coax cable. Now let's go ahead and talk about the types of connectors that you'll see on this cable. And by the way, visually speaking, all of these types of cable for coax will just look very similar to what plugs into the back of your television. And then on the end of that cable, you'll have one of these things. The first one would be something called a British naval connector. And what that would look like would be something like this right here. Okay. Now this is not exactly like the connector that you would put on the back of your television or back of your cable box, because this has a twist lock connector on it, whereas normally the one that goes on the back of your TV is just as a threaded connector. But that's similar to what that looks, and you can see in the center right there is the core where the single wire is used to send and receive data. There's also the white plastic core right there, or the cladding as well, and then there's some insulation that goes on with this as well to help protect the signal. So that would be a British naval connector that we see here. And then you might also see something called an attachment unit interface. And that would look something like this right here. The attachment unit interface would go like this. Here we would have a British naval connector on this end of the cable, and then the other end of the cable would plug into the back of your network card, which would have a similar connector, actually the same type of connector. Okay, that's how you would plug in the two British naval connectors. But then what's this side over here? That's what looks kind of like a gaming port. That would be a different kind of a connector that would then in turn probably plug into something like a vampire tap, which I'll show you here shortly. Okay, we'll get to that in just a moment. There would also be, actually let me just get to that right now, a vampire tap, just to make sure we have good continuity here. If we take a look at, where is it? This item right here. This is a vampire tap. So you see this connector right here? This is the same device, just two different angles of it. This is where, instead of using a British naval connector, we would use this D-shell shaped connector, And one end would go here, and the other end would go on the transceiver that I showed you in the previous picture there, all right? And then the actual cable itself, like the backbone, for example, would go through this portion right here, and there's a little pierced, or a pointed little device right in there that you tighten this thing down, and it actually pierces the outer jacket and all of the insulation right into the center core of the coax cable. Then the signal will then go through this device and then out through this D-shell connector here to your computer ultimately. And then here's some more indicator lights. You know, on the A+ exam, they like to know that you know what an indicator light is. Well, there they are. So that's the kind of an idea that we have here. Okay, so what we would have here is, again, let's start from the beginning there. We'd have these connectors right here, which are British Naval connectors. One end plugs into the back of your network card. The other end would plug into something like this, which would be your transceiver. Okay, that would be the other end of the connection. And then you would have the D-shell connector, which one end would plug in here, and then the other end would plug in here, like you can see. All right, and then it would be tapped into the backbone or trunk of the network. And then the other thing you would have to know about would be a T connector. This is likely what's going to actually plug into the back of your computer as well, depending upon the type of topology that's used. If you don't use the vampire tap method to connect ultimately to the trunk or to the backbone of the network, then you may instead just have a single cable running from one computer to the next, and it would be connected using a T connector like that we see right here. Now, I don't have a good resolution of this particular image, but you can see this is the network card. We come across our coax cable here. It has a British Naval connector right here that connects to this T-shaped adapter that we see right here, okay, which also connects to your network card. All right. Then what would happen is we could plug in another coax cable here and continue on to whatever the next computer was in our line. However, if this is the last computer in the line, we would have to instead put on a terminator. And you can see here it's just, you know, got a plastic, or rather a metal point on the end of it. This is just to prevent signal bounce, so that you don't have a signal that kind of echoes continuously. This will stop the signal and terminate that connection. So that's what that actually is there, would be a terminator. Okay? So those are some types of things that you would see in a coax network. But again, very unlikely that you'll see that in real life very much. Now, fiber is going to be a much better kind of a material to use for something like a backbone or any kind of a high-speed network. It also gives tremendous distance out of fiber that you can't get out of any of the other kind of media. Only thing is that fiber is very expensive. That's why we don't just use it everywhere. Also, the cable can be difficult to handle because what happens here is the core of it is going to be made of glass, which of course is fragile. So if you put a big kink in it, or you're too rough with it, you could crack or break the glass inside of it. You know, the cladding around it helps to protect it somewhat, but it can still be damaged. There's plastic as well, which might not give you as long a good of a signal, but at least it's more durable and it can handle a little bit more abuse. There's two different types of this cable. There's single mode fiber, which would be a yellow cable. You can visually identify it that way. And multi-mode, which would actually be orange. Okay. Now, what's the difference here between this single mode fiber and the multi-mode fiber? First of all, single mode fiber is only going to carry a single signal in it. So if this is my light, you know, this is like a little light bulb, and this is my light, emitting light right through here, it's going to send that light through my cable. I know it looks more like the Bride of Chucky or something like that, but just bear with me for a minute here. And it's a single mode will have only a single signal transmitting through it. Okay, that's all that's going to be going on. Multi-mode would be using additional signals, so multiple signals. And we might have another signal taking place simultaneously with our original one. Okay. Now with the single mode fiber, you're going to be able to get 3,000. I'm going to run out of space here, but let me try it. 3,000 meters, or also known as 9,840 feet. With a multi-mode fiber, you can get 2,000 meters, and I don't think you need to know this for A+. I'm just telling you this, so that you can identify, you know, the tremendous lengths that you can get out of this. 6,560 feet. Okay, so you can see here with fiber, you can get tremendous distance out of this type of cable. Also, keep in mind that for fiber, one of the key advantages of it is that it's immune to electromagnetic interference or radio frequency interference. That would be an important item to remember in terms of A+ exam objectives. Also, the types of connectors you'll see will probably be primarily these top two. That would be a straight-tipped or a square connector. And then there are also a couple of other types that are available. Actually, there's more than this, but there's a couple more here that we can just identify. One of those would be a lucent connector, and this is mostly used for telco types of applications. And then the last one would be a mechanical transfer. Actually, that should be MT instead of MJ, so that's an MT there. Mechanical transfer registered jack. That looks a lot like an RJ45 jack, except that instead of wires on the end of it, you'd actually have some kind of a fiber connection. And then I'll go ahead and show you a picture here shortly. Alright then, here we have a photograph of several of the different types of connectors. The first one we looked at there was a straight tip connector. Remember I told you earlier that looks a little bit like a coax. Yeah, because you twist on this metal part at the end, and instead of the copper coming out of the end of this, though, you have the material for the core of the fiber. Then we have the square connector type that we see here, and you can kind of identify that just because on the corners it's squared off. Okay, and then you have the lucent type connector, which just has a little clip right here to help retain it into place. And then you have this MT, where'd my stuff go here? MTRJ, the mechanical transfer registered jack. It's kind of small there, but I'll try to see if I can zoom in a little bit. That's just the final type of a connector you can see. And again, it has also a clip in here to hold it in place. But those are just a few of the different types. Again, I think you're going to mostly be seeing this one, the ST and the SC connectors. Finally then, you'll also be running into twisted pair, which is by far the most common type of cabling you're going to see. You have several different types of category cable. That's what CAT means, category. You have category 3. This uses between 2 to 4 twists per foot. CAT 5 implements between 3 and 4 twists per inch. Okay, as does CAT 5e, but CAT 5e includes some other enhancements which give you better signal integrity and which is more reliable for gigabit E. You can use gigabit Ethernet on either CAT 5 or a CAT 5e as well as CAT 6. Okay, it works on all three of those. But the latter two here are much more reliable for gigabit E, and so that's the preference if you're using that. And they all use 3 to 4 twists per inch down through here. Now, by the way, why do we actually twist this wire? Because you'll see here in this CAT 5e cable that I've kind of dissected that there are pairs that are all twisted around one another. Why is that? Well, if they just left two wires straight like this, then you would have a problem with crosstalk, which is where I'm sending a signal down this wire. Maybe I'm sending or receiving a file. Well, it will kind of overlap and interfere with this other wire. So you'll get some crosstalk involved in that. By twisting it around, we're able to mitigate that so that that's no longer an issue. And that's why this is twisted pair cabling. There's a couple of different types of twisted pair you can use. Unshielded twisted pair, or UTP, that's much more frequently used, and you'll probably see a lot of that. And it does not have any additional shielding or braiding or anything else to protect it other than the photograph that I just showed you, the fact that you have the twists, and around each individual wire, you'll have a little bit of insulation around each one as well. There's also shielded twisted pair, which uses an additional layer of braiding to be able to protect it against electromagnetic interference, for example. This might be the case if you're running some of this cable alongside of heavy machinery that might generate magnetic fields, or if you're running up in light fixtures or near light fixtures that'll have a ballast where the EMI could affect the reliability of that cable. Well, in that case, again, you'd have to use shielded twisted pair. The only thing is with STP, of course, again, you're going to run into more expense, so that's why you don't just use it everywhere. That's a $sign there if you can't figure that out. Okay, so that's a shielded twisted pair. Also, a couple of different types of cladding on the outside that you might see here as well, plenum rated as well as PVC. Normally, you can have PVC type of a plastic out there, but you may also have plenum rated. This is where if you are running the cable, maybe up in the lights or something like that, let's say a fire starts up there, electrical short, whatever, when it burns the outer jacket to your twisted pair cabling, PVC can emit noxious fumes. That's generally not considered a good thing in the workplace. We don't really like to suck in that kind of air. So the plenum rated will be more expensive, again, of course, but it's guaranteed that it will not emit those same noxious fumes. Hence the plenum rating. Now the types of connectors you'll see on the end of these would be RJ11. This would be pretty much just a conventional phone line, and that would go on only the end of CAT 3. You would not use that on the end of Cat 5 normally. Actually, you could. In my own home, for example, the electricians, when they wired the telephone jacks, they just used Cat 5, and they put an RJ11 jack on the end of it. But more commonly, you'll see RJ11 on the end of Cat 3, and this is what it looks like, just a normal phone plug. And you can see that there are 4 separate wires here. 1, 2, 3, 4. My pen's kind of faint there, but you get the idea. Okay, so just for normal landline types of phone jacks. There's also the RJ45 jack, which you've probably seen before. And this is the kind of a jack that you'll plug into the back of your network card. You plug it into the switch, plug it into a router, all those types of things. Plug it into hubs and the like. That is our most commonly used network connection. And then for sake of reference, let's take a look at the actual plug. Here's an RJ45 plug that you would see. It's crimped onto the end of a Cat 5e cable. That's what I've got here. There's also a specific order that this is wired in. You can actually do it in any order you want to, as long as it's consistent on both ends. The thing is, you want to normally make this the same kind of standard wiring order that you see here, so that if you ever have to interoperate with other companies or other wiring companies or other network administrators that are trying to cooperate with your design, then you have consistency here. The general order is, and you don't have to memorize this for A+, but you might if it was Net+, but the general order is orange, white, orange, green, white, blue, blue, white, green, brown, white, brown. Now, you might look at this and say, well, wait a minute, James, you got that wrong, because that's orange, white, orange, and then there's another orange, white. Well, the orange that you see right there, I don't know if that's very visible or not, that orange is just reflected in this plastic right here, in this clear plastic housing. It kind of created an orange reflection. That is actually a green-white cable. So it's orange, white, orange, green, white, blue, blue, white, green, brown, white, brown. Okay, that's the order it goes into. And then when you actually plug this into a hub, a switch, or a network interface card, these contacts right here that you can see, these are what actually make contact inside of those types of devices. Now, when you actually wire this, this is a side profile view, a macro view, so it's highly magnified, of the actual piercings that take place with this. You see, the individual wires that we looked at a moment ago, they will go into this portion right here. They'll just, be fed right through here. And then you'll take a crimper, which then clamps down on top of these plungers, and they will then press down using these piercings, these pointed tips down here. They'll pierce into the actual wire down here in this section. And if you want to see a close-up of it actually having done that, that's what this would be right here. Let me see if I can zoom this in a little bit as well. Okay, so now you can see here the plunger, which has been pushed down by the crimper, which is pierced into this, pierced through the insulation on the outside of the wire, and pierced through it. Now it's made a connection to it, so that when we plug this cable or this connector into, let's say, your network interface card, the connection that it'll make right here, the contact that it makes on top of this, will be continuous from there all the way down through the wire connection that we see through here. Okay, I used to be a technical editor for a kind of a rather famous, actually, A+ person that used to write college documents and stuff like that, or college curriculum for A+. And she always said that before you actually put this wire in here, you should strip all this insulation off the end of it. That was the silliest thing I ever heard. I've never seen a network administrator do that, and it's completely unnecessary because this will pierce right through it anyway. So it's just totally unnecessary. So I only say that to mention that if you're also reading other materials about how to create your own network wire, network cabling, and stuff like that, you do not have to strip off this individual wire insulation. The outer jacket you do have to strip off, but this type of wire, though, the actual wire insulation, you do not. And then also here, I've just made available for you up on nuggetlab.com just a document. It's a PDF file called cable.pdf, and this just identifies some other characteristics about the various types of cable. So, for example, RJ6, I mentioned earlier, is often used for the older satellite TV. RJ8 is also known as thick net cable, by the way, and it's used on an older 10-base-5 type of a network, which gives you 10 megabits per second, and the maximum length that you can use for this in meters is 50 meters for a drop. That would mean like you're taking it from the trunk or the bus and then running it to one of the clients, for example, and then 500 meters for the actual backbone. Okay, so you get the idea there. There's other types of things described here as well. Again, what you're more likely to run into is Cat5e using gigabit E, and then you can use any of these speeds with Cat5e, unless, of course, again, you have an intermediary network device that would slow you down. So, for example, maybe you have a 100 base T, rather a 100 megabit per second hub in the middle of your gigabit E network, like I mentioned in our last nugget. So these are the speeds you can get, and the maximum length with any of these twisted pair is going to be 100 meters. Now, do you have to memorize this entire thing? I wouldn't say that you need to do that, but I think that you should at least look at it and be able to identify, like, a true-false statement. For example, if I were to say that you could use RG8 for a 1,000 base T network, physical layer network, well, you would know that's not right, because here's a 1,000 base T for Cat6 or Cat5e. But it's not for RG6, RG8, any of these up here. So if you can identify it, at least in that respect, I think you'll be just fine for A+ exam objective purposes. In this nugget, we took a look at cables and connectors. We started off by taking a look at coax cable. Remember, this is the round cable that you can normally see plugged into the back of your television. Except that this type of coax cable for network interfaces is going to be a slightly different design, although it looks very similar. It also has a variety of connectors that we looked at. And then there's also the fiber optic type of cable. Remember, that has a core of glass or plastic, and it's very high speed, can go a great distance, but gee, it sure is expensive, and it might be kind of hard to work with because you have to be really careful about handling fiber optic cable. Also, I don't think you're going to see that, again, very much for A+ technicians. A+ technicians, however, are much more likely to see the twisted pair that we talked about, and you're going to see this primarily in 10100 and gigabit E networks. Well, I hope this has been informative for you, and I'd like to thank you for viewing.